Alright, let's do lead code. Have I done this question? No. Okay. Looks lots of text. I don't like lots of text. There are three lane road of what? There is a 3-lane road of length n that consists of n plus 1 points labeled 0 to n. Okay. A frog starts at point 0 in second lane and wants to jump to point n. Okay. However, there could be obstacles along the way. You're given an array of obstacles of length n plus 1, where each ranges from 0 to 3. If it's 0, there's no obstacles. Alright, so it's 1, 2, or 3. If it's 1 means it's lane 1, 2 means it's lane 2, 3 is lane 3, I guess. So we met most one obstacle in 3 lanes at each point. Oh wait. There'll be at most one obstacle in 3 lanes, in the 3 lanes at each point. Okay, makes sense. For example, if obstacle at point 2 is equal to 1, then there is an obstacle on lane 1 at point 2. And the frog can only travel from point I to point I plus 1 if there is not an obstacle on the lane at point I plus 1. Great. The frog can only travel from point I to point I plus 1 on the same lane if there's not. Yep. To avoid obstacles, the frog can also perform a side jump to another lane, even if they're not adjacent. Okay. So they can jump like all the way up. Okay. Oh, okay. Side jump to another lane. At the same point, if there is no obstacle on the new lane. For example, the frog can jump from lane. Yes. Return the minimum number of side jumps the frog needs to reach any lane at point n, starting from lane 2 at point 0. Minimum number of side jumps the frog needs to reach any lane at point n, starting from lane 2. Oh, okay, so 1, 2, 3, I guess. At point 0, there will be no obstacles on points 0 and n. Okay, good. So we have n's up to 10 to the power 5. So I'm guessing a linear approach. A linear approach is what they want. Can you do this using DP? Because I can think of the subproblem as the subproblems are going from 0 to each of these points. What's the minimum number of jumps? So the minimum number of jumps, minimum of side jumps to get to point 1 is 0. The minimum number of side jumps to get to point 2 is 1. Minimum of side jumps to get to point 3 is what? Okay, so you can have a DP per not position, but per position, but also per lane. So like if I want to get to point 3, I have to figure out, alright, What's the minimum number of jumps I can get to this point, and this point? Of course, this point is not possible. But also, actually, no, that's not right. That's not right. If I want to get to this point, then it will be dp from this point. Okay. But from this point, the minimum number of jumps to this point is, I have to consider jumping from here. Yeah, but what if I haven't, that dp doesn't really check out because I have to consider both ways. What if for each point I consider the minimum number of jumps it takes to get to that point, not jumping sideways. So in this case it will be infinity, this will be infinity, because I can't get to this point. This will be infinity. No, this will not be infinity, this will just be 1, because I can get from here. And the reason this is infinity is because I can't get from here to here. The reason this is infinity is because I can't get from here to here. Because it's a rock. There's a rock there. So, once I figure that out, I can reevaluate it and think, for the infinity values, for all the ones impossible to reach, can I reach that position using doing a side jump? Then it'll just be 1 plus that. And if there are any, so if there are any in those lanes that I can reach, and there is infinity, that infinity can be made just 1 plus. In fact, what you can do is once you calculate for each dp point, so let's say ij, for a particular I, let's say for example I0 is equal to infinity, and you have 1 is equal to infinity, you have 2 is equal to 3, what I can do is grab the minimum and set the rest, grab the minimum one and set the rest to be equal to the min of the minimum one, 3 plus 1, and what the original value was. Oh, but what if it's a rock? If it's a rock, then it stays infinity. So if not obstacle, So if there's a 0, then there's nothing there. If obstacle, yeah. So if obstacle at this position I, wait. Oh, wait a second. There's only one obstacle per point, I think. There's at most one obstacle in 3 lanes at each point. So that means if obstacle I does not equal to j. But it's not j. Maybe I should have thought this at 1. It's not equal to j plus 1. Then the min and it's not if statements. If I want it to be code correct, then that and infinite. Alright, so this will stay infinite, which is equal to 4 in this case. I'm just looking at this case here, and this will be equal to infinite. And this would stay, let's just pretend num jump so far to 2 is 3. Alright, so yeah, this is kind of difficult to think about. So let's just go through an example. Let's go through this example, I guess. Okay. So how do we do this? This will always be a 0, so what we can do is start with an array. Of infinite values, 1, 2, 3, 4, 5. Now this will be a 0. Now it's and then the base case could just be to apply this logic to here. So I'll go through all of these, find the minimum. The minimum is 0, and then apply this logic. For the base case, I know that this is going to be 1, so I could really just hard code this bit. And then I go, okay, so for each, how many jumps would it take to get to this position? Well, if there's a rock there, leave it as infinite. So in this case, there is a rock, so leave that there. This is going to be 1 plus the previous one if there's no rock. Here it's going to be 1 plus the previous one if there's no rock. Then I find the minimum. Minimum is 1, and So then I go through and I try to set each of these to 1 plus 1, which is 2. And this is already 2. This has a rock there, so I don't change it. And for infinity, I should have just done this. It's a bit hard to... 1. Let's do a dash for if it's infinity. And how many do I have? So I have 1. One, 2, 3, 4, 5. There we go. All right. Okay, then I calculate for each of these, what's the value? So that stays infinity because the previous one is infinity. And then I go here and I'm like, all right, can I? Yep, I can because this previous one is 1, so I can do it 2. Oh, except there's a rock here, so I can't. And then I go here, and it's like, there's no rock here, so make this a 3. Oh no, make this equal to 2, so the previous one. In fact, this will say 1, and then this will say 0. Oops. Yeah, my bad. Oops. So yeah, if I'm going sideways, then I can just like copy the number across. I don't add 1 to it. Only when I'm going sideways. So here I copy it across, and then I calculate. That will stay 1. Yep. And here there's rock. Can't reach here because previous one is dash. Can't reach here because there's a rock here, and here I can copy the 1 across. Then I find the minimum out of all of these, and I update each one if there's no rock. So here there's no rock. So I can make this a 2. And then here, I can try to copy the values across. There's a rock here, so I'm just gonna set this one to 2. So copy the values across. I can't copy the values across here, and I can't copy here because of the dash before. And then now I can go through each of these 2 and set it to be the min of whatever it was, and 2 plus 1. So here is going to be 3. Here is going to be infinity still. And then I copy the values across again, so that's 2. It's going to be 3. It's going to be infinity. And for this one, I guess we already found the answer, but we could also just complete it and just say this is going to be 3. Because it's 2 plus 1, and there's no rock there. And then I can just go through the last column and find the minimum value and return that. So that's how you do it. That should work. Now, okay, you can do it in. I know you can do it in constant time in linear time. So let me actually comment this out. And you can do it in O of 1 space, but is it worth doing in O of 1 space? It might be, because I'm just copying the values across. I might as well do it in O of 1 space. So if I just keep an array of 3 values, like 1, 0, 1, initially it's always going to be 1, 0, 1. So I initialize a vector of ints of dp, so of size 3, to be equal to 1, 0, 1, Now the logic would basically go through and set and copy them across. So the copying thing happens. If I can just do the copying thing by just checking for obstacle and then setting the corresponding obstacle value to 0. So for int, for int I in obstacle in obstacles, I could just set dp Yeah, it's fine. It's fine. If there are no obstacles, then continue. So if obstacle is equal to 0, if not an obstacle, then just continue. Just copy the values across, and the first one is always going to be 0, so I could just copy those across and just continue from there. And then I have, alright, so I know there is an obstacle, so I need to go obstacle value, and dp the obstacle value -1 is equal to infinity. So I just say max int. I think it's int max. I wonder if there's a function to just get the min of, I think there is, begin dp.end. Is there always an answer? I think so, because there's only one obstacle per. It is possible to jump, so. Yeah, it should be possible. So that means I can guarantee that the min value here is always going to be int min jumps. And then go through each of the values and set them to be the min of 0 I less than 3 plus I. So if the obstacle -1 is equal to I, then continue, I think. Because I don't want to set the Then I'll set the dp of I to be equal to the min of min jumps plus 1, and what else? The actual value of it so far, so dpi. Yep, and then at the end return dp, the min value of dp.begin, dp.end. I don't know if this, I've never actually done this before, so we'll see if that is a thing. Might have to check the docs. That's annoying. Oh, what? This. Okay. And what else? Line 3 has an obstacle, so I'm going to mark that as something else. Maybe O? X. That's 0. No, that's 1, 0, 1. This is 1, 0, 1 because I'm continuing. This is 1, 0. X, so it's infinity. In fact, this is all going to be zeros. It's going to be 1. This is going to be 1, 1. One. It's going to be 1 as well. It's going to be 2. 1. It's going to be 1. It's going to be 1. This obstacle here means I need to jump out, and okay, this needs to be 2. Hold on. This is going to be 2. Yeah, that's going to be 2. 2. And oops. And 2. So that should be the answer. So apparently I'm printing out 3. I see. Yes, the logic. I shouldn't be jumping if there is no obstacle. In fact, it's probably easiest to just like say add a 0 here. Say this. Say this, and yeah. All the way up to 4. Okay, give that a go. What? Infinite max int. Int max, I think. I should never be able to get there. Also, this should be from 1 to I. Oh, okay, so that was the issue. Please. Algorithm goals. Yes. Thank you.